Hey, welcome to The Explainer. Have you ever tried to read a psychology paper and felt like you accidentally walked into a high-level math class? Yeah, you are definitely not alone. So today, we're going to tackle a big question a lot of people have. Why on earth is psychology so full of statistics?
Right, let's just put it right there on the screen. It can feel like this huge wall of numbers, a barrier standing between you and all the fascinating stuff about the human mind. But what if I told you those numbers aren't a wall at all? What if they're actually a bridge?
This quote really gets to the heart of it. It's not that psychologists are bad at science and need numbers to prop up their work. No, it's the opposite. They rely on stats because the thing they've chosen to study, us, people, is just unbelievably complex. I mean, just think about it for a second. An atom is going to do what an atom does, pretty predictably. But people, oh man, every single one of us is different. We've got different moods, histories, motivations. It's messy. And statistics is the special tool that lets researchers slice through all that wonderful, chaotic human mess to find patterns that are actually meaningful.
Okay, so let's dive in. To really get how statistics solves this massive problem, we kind of have to learn its basic language first. And it all starts with one really simple but super powerful idea. And that idea is the variable. It's exactly what it sounds like, something that varies. If every single person on Earth was the exact same height, then height would be a constant. But since it can take on all these different values, it's a variable. This is the absolute fundamental building block of any kind of data.
And these variables, they basically come in two main flavors. Over on the left, you've got categorical variables. Think of these like buckets or labels you can sort things into. Like for survival status, you're either in the survived bucket or the died bucket. Simple. Then on the right, you have scale or numeric variables. These are things you can actually measure with a number, like your age, your height, or how many hours you slept. So one is about what group you're in. The other is about how much of something there is. So we have our building blocks. Now let's see how this stuff actually works in the real world. Because once you know what your variables are, you can start telling some pretty incredible stories with data. And our first story? Well, it's an epic one.
We all know the story of the Titanic. Well, researchers have the actual passenger data, which gives us this powerful, real-world chance to see how we can summarize a categorical variable, in this case, maybe the ultimate categorical variable, did you live or did you die? So if we just count up the people in each of those two buckets, we get what's called a frequency table. And yeah, you can see the numbers. 863 people died, 450 survived. The information's there, but it's just a list, right? It doesn't exactly hit you in the gut. But look what happens when we take those exact same numbers and turn them into a picture. All of a sudden, bam, the story is crystal clear. That giant towering bar for died tells you about the scale of the tragedy in a way that a simple table of numbers just never could. And that, right there, is the first bit of magic in statistics. It's about taking a simple count, a simple table of data, and turning it into a clear, powerful visual insight that's impossible to ignore. It makes the story jump right off the page. So here's the key takeaway so far. Different kinds of data need different kinds of tools. Counting and making a bar chart worked perfectly for those categories on the Titanic. But what about when we're dealing with numbers, with those numeric scale variables?
All right, let's look at a classic psychology experiment. Imagine researchers gave 10 patients one type of sleeping pill and then another 10 patients a totally different sleeping pill. The question is dead simple. Which one helps people sleep more?
So, unlike the Titanic data, we're not just sorting people into groups. This time we're actually measuring something. The number of extra hours of sleep each person got. That's a scale variable. And if we just made a chart with 20 different bars for every single person, it'd be a total mess. We need a cleaner way to summarize this.
And here's how it's done. Instead of just counting, we calculate the mean, which is just a fancy word for the average. We take all 10 of those individual sleep numbers from group 1, and we boil them all down to one single number, 0.75 hours. We do the exact same thing for group 2, and we get 2.33 hours. This right here shows you the power of the average.
This single number, 2.33, it represents the experience of an entire group of people. It cuts right through all the individual noise and lets us make a direct comparison. And it's pretty clear that second drug seems way more effective. Okay, so we've seen how stats helps us find stories in both categories and numbers. But let's get to the real question. Why should any of this matter to you if you're not planning on being a research psychologist? It matters because this language of data, it's absolutely everywhere. Understanding the basics means you can actually read a scientific article in any field, not just psych, and get what's going on. It helps you design smarter projects no matter what your job is. And most importantly, it gives you the power to look at all the charts and numbers thrown at you every day in the news and online and decide for yourself if they actually make sense. It is a critical skill for just living in the modern world. So the next time you see a chart or a study, I want you to try something. Don't see it as a scary wall of numbers. See it as a story that's just waiting to be told. The real question isn't why psychology uses so much statistics. The much more interesting question is, what amazing stories are hiding in the data all around us, just waiting for someone like you to come along and uncover them?